Hey there, my name is Logan Clark, and I'm a PhD student at the University of Virginia working with Dr. Sara Riggs. This year I'm presenting some late-breaking preliminary results from my dissertation work. In one sentence, the main takeaway of these initial results is that when users reach to select objects in VR, measures of their movement speed, efficiency, planning, and smoothness depend on the location of the objects and the hand used to select them. Digging a little deeper, my work is focused on a specific type of measure called kinematic metrics, which use data describing the speed of the hand over time to measure useful properties of arm movements. These metrics can quantify things like the efficiency, speed, planning, and smoothness of reaching movements. And since VR systems already record the movement data that we need to calculate kinematic metrics, there are several promising potential applications of these metrics in virtual reality. These include measuring arm function recovery as part of VR-based rehab programs, providing quantitative usability measures to evaluate VR systems, and monitoring students' progress during VR-based motor skills training. Now, from past work, we know that kinematic metrics can sometimes be influenced by the properties of the tasks during which they're measured, but it isn't yet clear how the properties of VR-based reaching tasks might influence these common kinematic metrics. So that's what we decided to explore in this current work. So in this study, we had 20 participants perform a 3D reaching task in virtual reality. The task involved moving from a yellow starting position to select red targets that appeared one by one at different locations in 3D space. Participants moved to select targets in 5 different directions, and they perform the task on either the left or right side of the body midline using the left or right hand. We captured the kinematic data from each movement and calculated each of our metrics of interest, and then used separate multi-level linear models to examine how task properties impacted each metric. Here we focused on exploring the effects of hand and movement direction, averaged across movements performed on both sides of the body midline. And in this initial analysis, we found that all 10 metrics were significantly impacted by some combination of hand and movement direction. These effects reflected several distinct ways that hand used and movement direction impact the values of these kinematic metrics. A few of these patterns are summarized here, and the rest are covered in more detail in our paper. Together, these initial results suggest that researchers and designers should consider the influence of hand use and movement direction when interpreting kinematic metrics captured in VR. In future work, we'll seek to enable this by exploring how these and other task properties impact the values of an even broader set of kinematic metrics. I'd encourage you to check out our paper for more details on this work, or feel free to reach out to me at ldclark@virginia.edu. Thank you.